Chapter 6, Systems of Equations, Day 8. This is Day 2 of Elimination. So I'd like you to pause the video and try these two questions, solving by elimination. These are pretty easy ones. And then you can check back to the notes to see if you got them correct. And if you need more explanation, hopefully with today's lesson, it will become more clear if you didn't get them correct. So here's some review. With elimination, we line up like terms. Then sometimes we have to multiply each equation or sometimes both equations by a value so that both equations have the same but opposite coefficients in front of the variable. Then we combine and add them so that one of the variables is eliminated. We solve for that variable and then we substitute the value of that variable into one of the original equations and solve again. So these next two examples, okay, we aren't going to be able to get away with just multiplying one of the equations by something. So if we go back to this, if I just multiply this top equation by 3, that is going to give me 3y right here. It's also going to give me 3x. And it's also going to give me 9, but that's how I eliminate, is when the coefficients in front of one of the variables are the same but opposite values. In this one over here, it's already set up that way, so you don't have to multiply either equation by anything. If you look at this first example today, these are not the same or opposite, and neither are these. And there's really not just one number that we can multiply by. But if you notice that we do have a positive and a negative, so if these were the same coefficients in front, then we would be able to eliminate. Well, if this was negative 6y and this was positive 6y, then these terms will eliminate. But we can't just make it that way. But what we can do is we can figure out what could we multiply this top equation by so that negative 2y becomes negative 6y. Well, we can multiply it by 3, because then when we multiply negative 15 by 3, we would get negative 45. And when we multiply the 3 times 2y, that would give negative 2y, that would give us the negative 6y. And then when we multiply the 3 times the 5x, that gives us 15x. And so again, this equation becomes 15x minus 6y equals negative 45. So now we have to figure out what could we multiply this bottom equation by so that that y value become positive 6. Well, if we multiply the 3y by 2, that will give us this 6y. But remember, we have to multiply each of the terms in the equation by 2. So the 12 times 2 would become 24, and the 3x times 2 would become 6x. So now our second equation becomes 6x plus 6y equals 24. So now what we're going to do is we are going to add the two equations to eliminate one of the variables. So if I add these two equations, 15x and 6x is 21x. The positive and negative 6y add up to 0, they're eliminated, and negative 45 plus 24 gives me negative 21. Now it's really easy to solve. I just divide by 21 on each side, and that gives me my x value is equal to negative 1. So I found my x value here. So now all I have to do is do this fifth step right here. What I did was I solved for the variable once I eliminated. Now I can do this step right here, which is substitute this variable back into one of the original equations. Just pick whichever one. I'll go ahead and put it into this second equation. So then that is 3 times my x value of negative 1 plus 3 times my y value is equal to 12. You could use the equations that you got when you multiplied, but that just makes your numbers bigger. So 3 times -1 is -3 plus 3y equals 12. Then we add 3 to each side. We just keep solving this like we normally would, and that gives us 3y equals 15. Divide by 3, and we get our y value is 5. So now we know our solution to this system of equation is the ordered pair -1, 5. So that is our solution to that system of equations. So these just get slightly more complicated because we have to multiply both equations by a certain value. So what I would like you to do with number 2 is I would like you to pause the video and see if you can think of some number to multiply each equation by so that one of the variables is eliminated. And then restart the video and see if the way that you did it will work. Well, one way to do this is to multiply the top equation by a -1, because that will give you -8 for the x's, and then of course you would have to multiply each of the other terms by -1, including the n term. And then if you multiply the second equation by 4, what that's going to give you is 8x minus 20y equals 27 times 4 is 108. So that's one way you could do it. Or really, I could have just kept that top equation and multiplied by a -4 and just got rid of that. So there's two options, okay? Or you could have worked with the y's. And one way, what you could have done also is if you would have multiplied this top equation by -5 and the bottom equation by +3, what that would give you for that y term would have been 15y and -15y. And so those would cancel out. So I just wanted on that question for you to get an idea of if you're starting to understand what values you should multiply by. So let's take a look and try another example. Okay, it says use elimination. So that means we have to add the two equations together to get one of the variables to eliminate. So again, can you look at this first equation, this first problem, number 3, and figure out what would you multiply one or both of the equations by to get one of the values to eliminate? Pause the video and see if you can find a strategy. All right, well, I can see that we have positive and negative, and so if I multiply this top equation by 2, that is going to give me -4x, and then with the positive 4x below it, it will add up to 0. But again, remember, you have to multiply each of the terms by the 2, so that is going to give me 10y, and it's also going to give me -4. And so now when I add these together, I would get that. I'm going to use a different color here. So when I take the -4x and I add the 4x together, there's my variable that eliminates. But the problem here is that when I add up the 10y, right here, the 10y, and the -10y, that also adds up to 0. So I have 0 is equal to 0. And is 0 equal to 0? Yes, that is true. So this is, remember, what it looks like when there is infinitely many solutions. Okay. It's your turn to solve number 4. So pause the video and see if you can solve number 4 correctly. Go ahead and not only multiply to figure out what eliminates, but also finish solving before you restart the video. Okay, well, what you should have gotten, hopefully, is something like 0 is equal to 10. Well, it's not equal to 10. So this is the kind that is no solution. Now, if you did not get the right values here, what I did is I would have multiplied this top equation by 3, because then that would give me negative 3x, that would give me 21y, and it would give me 15 on the other side. And so when I add these together now, the negative 3x and the positive 3x add up to 0, but so do, oops, I miswrote this, this was 21, and so do 21y and negative 20y, and that's where I got 0 is equal to 10. But that's not true, so no solution. All right, so again, reminder, when solving a system with algebra, either substitution or elimination, if the result is a false statement, like negative 2 is equal to 7, we know that's not true, so it's no solution. If it results in a true statement, then you have infinitely many solutions. All right, here's our last problem. We're going to do an application problem. It says the RHS student council members are making blankets to give to shelters. This week, they made 3 twin-size blankets and 7 queen-size blankets for a total, using a total of 71 meters of fabric to make those blankets. But last week, the members completed 8 twin-size blankets and 4 queen-size blankets, which required 72 meters of fabric. So how much fabric are they using for each blanket? And this would be kind of a tough one to guess and check. So let's let X be equal to the number of the amount of fabric, or number of meters of fabric for the twin size blankets, okay? And let's let Y equal the number of meters of fabric for a queen size blanket. So now, in the first scenario, 3 twin size blankets times the number of meters of fabric for those twin blankets. So you take the number of, let's say it takes 10 meters of fabric, so then 3 times 10 would be the amount of fabric used for the twin blankets. And then we add that with the 7 queen size ones that were made times the number of meters of fabric for each one of those. So again, if it was 10 meters for the queen, it would be 70 meters total. But we know that those aren't the values that work, because they only use 71 total meters of fabric for that scenario. So now we can go ahead and set up an equation for, so I'll go ahead and put that down as our first equation. So 3x plus 7y equals 71. But in the second example, now what we have is we have that they made 8 twin size blankets, so 8 blankets times the number of meters of fabric used for each twin size blanket, added with 4 queen size blankets, multiply that by the amount of fabric for each one of those, and then you add the amount of fabric for the queen size plus the twin size, and that was a total of 72 meters. So we have a system of equations here, and we can solve this. This is a great one to solve with elimination. But we're going to have to multiply both equations by a number to get one of the variables to eliminate. So in this first equation, I could actually multiply each of the numbers by 8. And when I do that, I have to multiply each value, so that is going to give me 24x plus 56y equals 568. Again, this is a calculator problem. Okay? The second equation, I am going to multiply everything by -3. And so that's going to give me negative 24x minus 12y equals, and then 72 times negative 3 gives me negative 216. So now, when I solve this with elimination, I'm going to add these together. I'm going to add these two equations together, and notice that the x's are going to eliminate. And then 56 plus negative 12 is going to give me 44y equals, and then 568 plus negative 216 is going to give me 352. Now I just divide each side by 44, and I get y is equal to 8. So 8 meters of fabric is used for each queen size blanket. So now how do I find out how many meters of fabric are used for the twin size? Well, now I take the y value of 8 and I plug it into one of the two original equations. So I'll just take the first equation, that when we did 3 twin size blankets times the number of twin size fabric, or number of meters used for a twin size blanket, plus 7 times 8, because 7 queen blankets were made and each one of them takes 8 meters of fabric, so a total of 56 there. And that total amount of fabric that we used was 71. So now when I take 71 and I subtract 56, because remember this was 3x plus 56 equals 71, that gives me 15. So 3x equals 15. So divide by 3 and x equals 5. So 5, each twin size blanket, so 5 meters of fabric for each twin. So this is how, again, another example of a system of equations application. This is the end of our day 8 lesson.